So it's quiz 302 part 2. We're going to talk about some fraction multiplication really quickly. The first thing to remember is if it is already proper or improper fraction, you multiply the numerators, multiply the denominators. So in this case, this is a 1/3 by 2/3 yard. So what is the area of the rectangular yard? You multiply the numerators, 1 times 2 is 2. You multiply the denominators, 3 times 3 is 9. Reduce, simplify. We think, are there any 2's in 9 or anything that we can take out that are similar factors? Nope, there's not. So it is 2/9 of a yard squared. That's it. Okay, that's perfect. We can scroll up to see if we did that correctly in a second. Boop, well done. What's the next one? So this one is saying we have a rectangle that's 2/5 of an inch long and 1/3 of an inch wide. So what's the area of this rectangle? They're already proper fractions. So you just write them. You multiply the numerators, 2 times 1, the top number, numerator. You multiply the denominators, 15. Are there any 2's? Nope. Anything in 15? 15 is only 1, 3, 5, and 15. 3 times 5 is 15, and 1 times 5 is 15. So that's it. So it's 2/15 inches squared is the area of the rectangle. Great job. 2/15. Okay, finally, this last quick one. Again, I think you guys have it. So, right, this looks like it's 3/8. And it, again, is in simplest form. It's reduced all the way because there's no 3, there's no 8 is only 2 times 2 times 2, or 2 times 4, or 1 times 8, and 3 is prime. It's only 1 in itself. Okay, so again, we just multiplied the numerator and the denominator. Now we're going to move on to these examples. These examples contain what we call mixed numbers. This is a mixed number, 8 2/3, 5 3/4. A mixed number is just a fraction with a whole number. Now, the first thing we need to do fraction multiplication is to change that mixed number into an improper fraction. We do that by multiplying the whole number by the denominator. And that makes sense, right? That makes sense because if I have, let's do 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I only have 2/3 of those. I'm cutting them all into thirds. And then we want to make sure we only have these 2/3 right here. This area, we have this whole one, 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 this whole thirds, right? So that's going to be 3 times 8. We have 3, 6, 9, 12, 15, 18, 21, 24. But we still have these 2/3 here. I didn't circle that area right there. That's not circled. That's not shaded in. Okay. So then that means 8 times 3, the denominator, that's how we get that, equals 24. That's the first step. Then you add that to the numerator, 2. See, we add that to these 2 because we have these 8/3. We have all of those 8/3, that whole, that's 8 wholes. So then we end up, if you counted each of those that's shaded, or, everyone but this one is shaded, you would end up with 26/3. That's the visual of what's happening and why those steps work, right? And then plus 2, and then you put it straight over that same denominator. Okay, same with over here. We do 5 times 4 plus 3. That's going to be 23/4. Here you can reduce right here if you want. I see a 2, or you can just multiply and simplify, put in simplest form afterwards. We can use a calculator because that's okay, because we're testing different ideas. 26 times 23 equals, so I'm going this way just for space reasons, 598 in the numerator because we just multiplied straight across, and 12. 3 times 4 is 12. All right, they're even. I'm going to divide by 2. Let's see, I'm going to divide by 2, I'm going to divide by 2. I'm